In this session, we will perform the baseline energy simulation. So the baseline is intended to provide a starting benchmark. So we will get everything set up and then we'll run a simulation and take a look at the report. So when the analytical space model opens up in Energy Simulator, we can see what actually gets exported. It's really a collection of the spaces or rooms that were in the building model with data on each surface of that room, defining what that surface is, what type of wall makes up that surface, or if it's a window or a door or a roof. And we can see that over here in the project tree. So this is part of EcoSim Energy Simulator always has this project tree, which is a list of all the rooms or spaces that were exported from the building model. And I can drill down into that list and look at any room in particular, such as the gymnasium. If I expand that, you can see that that has surfaces and components. If I expand those surfaces, you can see there's a large number of surfaces on that gymnasium. Now we also have our tools across the ribbon, just as we do in Building Designer. We have our two views of the model here. Of course, we have available up to 8, but I've got 2 open here. And the typical view tools for zooming and rotating that model. We also have this notification dialog dock down here, and that just gives us some notifications such as any potential errors or warnings. We just have one message at this point. So once we've initially opened up that analytical space model, the first thing we want to do is validate it. Make sure all the settings are correct. So I'm going to open the validation tool. So again, we're going to see that project tree here on the left. And then we've got tabs here. So the first one we're going to take a look at here is the energy settings. So this is some basic information about our building. For instance, the units that we're working in, we're going to work in imperial units here. The calculation standard, which is ASHRAE here in the US, so that will be our standard. We're in North America, the United States. This particular project is in Raleigh, North Carolina, so that information is correct. And for the weather profile, we're going to use the Raleigh-Durham International Airport. If you would need to change any of these, you just pull down and pick from the list of available weather profiles. That weather profile is going to set our climate moisture zone. And then, of course, we have our ASHRAE 2010. That's the actual standard that we're going to use. For the building type, I'm going to actually change this. Rather than sports and exercise, I'm going to change that to school and university library. Because it says, even though it's a gymnasium, it's part of a school, and this is setting up many of the standards we use, such as operating hours. Schools have different operating hours than other types of buildings. And so that's going to be a better fit. Once I've made all those changes, I'm going to select Apply. Then I'm going to switch over to the next tab, which is Room tabs. So this is taking the rooms or the spaces that were in the building model, and it basically maps them to a corresponding room type in the ASHRAE standard, the 2010 ASHRAE standard. And most of these should have mapped correctly. If you had any not mapped correctly, they would be highlighted in pink, and you would simply have to pull down the menu and find a room type that was appropriate. And once you've done that, you would again select Apply. On the next tab, we have zones. So these rooms can be divided into zones. There's a few that get set up by default. So all rooms is a zone that includes all the rooms and spaces, keeping in mind we don't just have the occupiable spaces, but if we have plenum spaces above a ceiling, those are also included here. So when we select floor 1, that's all the occupiable rooms, but not the plenum spaces. So this particular building's only 1 floor, so that's why we only have floor 1. If it were a multi-story building, you would actually have all the rooms zoned by floor. And we could add additional zones if we needed to. We can work with those for this quick start. Now the constructions are the actual building materials that make up the building. So as I said, each of those rooms has information on the surfaces. And so we're using what are called conceptual constructions. It basically means we predefined a wall type that is going to be used for any exposed wall. Any exterior wall will have this particular wall type. It's just a CMU block with a brick face on it. And same is true for the windows. Every window in the project will be this single pane glazing and so forth. Now we'll come back later in some of the other exercises and we'll make some changes to those, and we'll start to adjust those materials so that we can, do things like add more insulation and see if that affects the energy in the building. So we're going to close this dialog. We've got everything set up correctly. I still do have this message here about this mains water temperature schedule. I'm going to double click on that. That's going to open the dialog where that is set. And we can see here it's highlighted in pink that hasn't been set. So the mains water temperature is just the temperature of the water that comes in from the main. So the water that's delivered to the building. And so we're just going to set that to this HVAC template always 10 value. A couple of other things we might want to set here, such as this usage category. We're going to switch this to a developed rural area. That just defines a little bit about the site. The other thing I'm going to do is turn on this daylight savings time so that we adjust for daylight savings time as we do our calculations. And we'll apply that and select OK. And the final thing we're going to do is set up an HVAC or select an HVAC system to include in our simulation. So I'm going to go to the data managers and we're going to select the HVAC system. So if you look on the project tab here in the HVAC manager, you'll see that a few HVAC systems have already been selected for this particular project. And so those are the ones we're going to work with. If you go to the application tab, you'll see there's a library of different HVAC systems, and any of those can be copied to the project where they can then be adjusted and assigned to the rooms in the project. I'm going to go back to that project tab. So we're going to start with this, the PTAC air-cooled DX with electric heat. So I'm going to select it here. What I basically need to do here is get that particular HVAC system assigned to all the rooms in this building. So I can come here and over here in the graphic area. So if I double click on this, it's going to open the properties dialog for that particular HVAC system. And basically I want to take the available rooms that I have and assign them to this component. So I'm going to select my zone for floor 1. I don't need to assign the plenum spaces to this system, just the conditioned rooms. List all those rooms here then in the left hand field, and I'm just going to select all of them and move them to the right. Then I can close that dialog, and once I hit apply, those will be assigned. Now it does give you a warning here that the other HVAC systems listed here have not been assigned to rooms. That's fine. We're going to work with these one at a time. So then I'm going to select OK and close that dialog. So now that we've done that, we're ready to run the simulation. So then I'm going to go to the Calculations tab, and I'm going to select the simulation tool. So I just want to make sure I have the school selected, and then I'm going to just select again the floor 1 rooms, all the conditioned space. I want to give this simulation a name, so I'm going to call it the baseline simulation. And we'll go ahead and add on to here, it has the PTAC electric heat. Probably put a description as well, and we'll just make that the baseline simulation. Now I want to make sure I've got the right HVAC system selected here. You can see that list that we saw before, so I want to make sure I select that PTAC air-cooled DX with electric heat. Of course, we want to show our results on completion. Our weather data should be Raleigh-Durham International Airport. And that sets up those heating and cooling design days that we're designing for. And then as far as our run period, we're just going to select full year. So we run the simulation for the entire year. And then I'll select Start. And it'll start running that simulation. It's going to take a few minutes, and then we'll open it up and take a look. So when the simulation finishes running, the report will actually open up. Now that report is saved here within the software, but if you'd like to save it for instance, to a PDF file, you can use the save icon here and then save it out to another file. But let's take a look at the report. So on the front page here, just a little bit of information about the what building it is, the heating and design cooling days, the HVAC system, so just some details and facts. We'll go to the Summary Results tab. Building Utility Performance Summary just gives you an overall total energy usage for the building. But if we come down here to the end uses, for instance, we can actually see where some of that energy is going, how much of the electricity is being used for heating versus cooling versus interior lighting, for instance, and interior equipment. We can also calculate the room daylighting, how much daylight each room is receiving. Now, in this particular simulation, we didn't have that feature turned on, so there's no values in there. We'll run another one with that turned on so we can see the effect of the daylighting. So let's go ahead and close that, and let's turn on that setting for the daylighting, and we'll run this one more time. So I'm going to go back to the Home tab, and we're going to do a global change. So we can make all kinds of changes to the data that's on these rooms. We could do it individually through the project tree, but oftentimes it would be much easier to select all the rooms at once and make a change. So I'm going to come down to my zones and select floor 1. That's going to select, again, all the conditioned rooms in the building. And we're going to make a change to the lighting settings. So I'm going to pull down this lighting setting, all kinds of settings here. The one we're going to change is what we call fraction replaceable. So I'm going to click that on. That means I want to change that setting. And I'm going to change it to 0.9. What this means is it's going to allow 90% of the interior lighting to be replaced by daylight when the daylight is sufficient. So if there's enough daylight coming into the room, any particular room, the lights can be turned off, or most of the lights, 90% of them. So we're going to apply, and that's going to make that change for the entire building. So I'm going to close that. I'm going to go back to the Calculations tab. Open up the simulations again, same settings. I want to select floor run. Now I'm going to give this simulation a name. So I'm going to call this baseline simulation with daylight. And then again, put in the HVAC system, PTAC electric heat. And put in a description. Again, make sure I have the correct HVAC system selected. Got my weather profile. I'm going to select full year, and we're going to just start this up again. So when that finishes processing, it's going to open up. I'm going to slide that over here, and we're going to open up the original one as well. So I can just click it in my simulation viewer. I'm just going to put those side by side so we can take a look at them and take a look at the summary results. So let's just take a look at those end uses number. Remember that the report here on the left is the one that considered daylighting, and the one here on the right did not. So if we compare those two reports, for instance, we could look at the end uses here, see where the electricity is being used. Remember, this report on the left is the one with the daylight turned on, and this one on the right is the original report that was run. So we can see in the original report, the electricity used by the interior lighting was around 203,000 BTUs. And when we look at the one where we considered daylighting, we could reduce that substantially. It's down to 158,000. You might also notice that the cooling load has decreased by a little, because if your interior lights are not on, then that's not generating heat from the lights. Of course, that also means that the heating load increased a little bit because of the fact that you may have the lights off and not generate that heat. So that's the base simulations. Now you'll go make some changes to the building and then come back and run some additional simulations in Energy Simulator.